last time we finished a chapter named Elements, Compounds and Mixtures, and through WhatsApp I have given exercise for this one, exercise solutions for exercise 3A, and in the days to come you also try 3B, and now we're giving you the solutions for exercise 3B. Now we'll be starting a new lesson, that is language of chemistry. Language of chemistry. You must be thinking, oh, what kind of language this is? Chemistry also has language. The language is the medium through which we communicate with each other. So, in chemistry, say for example, if I write capital letter H, then in English it is alphabet H. But in chemistry it is hydrogen. If I write H2O, then for English it is not understood. It is simply H and subscript 2 and O. But for chemistry it has the meaning, and that is water. H2O means water. So that's why chemistry also has its own language. For example, math. In math, if I write ROT root, then it means value. But the same word if I write in biology, it means parts of plant. The same root if I write in English, it means base. So, the same word will have different meaning in different subjects. That's why each and every subject has its own language. So, we'll be learning now the language of chemistry. Language of chemistry. Okay, so language of chemistry. And for starting language of chemistry, first and foremost thing what we learn is symbols. Symbols. So as you take birth, what is the first and foremost thing the parents do is they christen your name, they keep your name. Every culture, every religion has their own way of christening the name, of giving the name, so that the society come to know about you by your name, so that you will have your identity. So similarly, before starting this chemistry, first of all, elements are given the name, and since the name cannot be used now and then, because of the lack of time, because of the lack of space, so we give symbols as your parents give you nicknames. As your parents gives you nicknames. Similarly, here also in chemistry we give nickname to the elements, and this nickname is symbols. So, what are symbols? A symbol is the shorthand representation for the atom of a specific element. Each chemical element has its own unique symbol. So, what is a symbol? A symbol is the shorthand representation for the atom of a specific element, or in short you can say symbol is the short name of an element. Symbol is a short name of an element. Short name of an element. And each element has unique symbol. H means hydrogen, and H doesn't mean any other element except hydrogen. C means carbon only, and there is no other element whose symbol is C. That means it has unique symbol. Each element has unique symbol. The use of symbols for the elements existed long before a systematic method was developed. Now we are using systematic method for assigning symbol to elements. But before this also, long back, okay, so long before, they used to use symbols for elements. The alchemist means the chemist of olden days are called alchemists. Associated the symbols of the planets not only with the days of a week, but also with the 7 metals known at that time: gold, silver, iron, mercury, tin, copper and lead. So these all chemists, they not only assign name of the planets to week. For example, we have this one in our common term, if we go, then so Mangal means Mars, then Brihaspati means Jupiter. So the names of the planets are given to the name of the days of the week. Similarly, they gave symbol to the elements, the metals known those days. There were only 7 metals known those days, and they are gold, silver, iron, mercury, tin, copper and lead. But now number of elements is more than these. By the beginning of 19th century, 26 elements were known. So then there were only 7 elements. Now by the beginning of 19th century only, that means by the start of 1900 only, 26 elements were known. Okay, by the beginning of 19th century, means 18th means we say 19th, 18th finish means 1800. Okay, so 26 elements were known, which increased up to 81 in the 20th century. That means by the beginning of 1900 itself, 1900 we say 1900 over, that means 20th century has started. 20th century has started. So 81 elements in the 20th century. That means elements are increasing more and more. That means there is a big necessity for symbols. The symbols which alchemists gave is insufficient now. So as more elements were discovered, the need for symbolic representation for these elements became more evident. In the 19th century, a Swedish chemist, John Jacob Berzelius. What is the name of the chemist? John Jacob Berzelius, who is the first one to assign systematic symbols to the elements. Who assigned systematic symbols to the elements. So systematically assign the first letter of a name in capital as the symbol of elements, such as O for oxygen, H for hydrogen, and so on, which was soon accepted by chemists everywhere. This later on formed the basis of IUPAC. What is IUPAC? International Union of Pure and Applied Chemistry. System of chemical symbols and formulae. So the first one to assign systematic symbols to the elements is Swedish chemist John Jacob Berzelius. Nowadays, this responsibility of assigning symbols goes to IUPAC, that is International Union of Pure and Applied Chemistry. So how we assign symbols, let's see. Each element, number one, each element is denoted by a symbol which is usually the first letter of its name in English or Latin, written in capital. So, he assigns symbols in 3 ways. Number one is assigning first letter of the name itself in capital. Assigning first letter of the name itself in capital. Number example, you can see the example here. Oxygen is an element, it is denoted by the symbol O. So oxygen, what is the first letter? O, and the symbol for oxygen is O. Similarly, hydrogen is denoted by the symbol H. The first letter of hydrogen is H, but it has to be, for symbol it has to be in capital. First letter has to be in capital. Then nowadays, IUPAC, International Union of Pure and Applied Chemistry, approves the names and symbols of elements. Nowadays, who takes the responsibility of approving and giving symbols to the elements? It is IUPAC. However, when the first letter of more than one element is the same, the symbol is denoted by 2 letters. Now, if the element has same, if two elements have same first letter, then Then how to assign symbols to these elements? The symbol is denoted by two letters. The first letter is written in capital while the second is written in small letter. So first letter is written in capital itself and the second letter in small. Example, carbon, cobalt, calcium, chromium and chlorine. You can see these 5 elements. First letter is C only. Carbon, cobalt, calcium, chromium, chlorine, all are starting with the letter C. Whose first letter is C? Carbon is denoted by the symbol C. Now, C, one letter, single letter C is given for carbon. That means it cannot be used for other elements. Then cobalt is denoted by two letters. C, capital, and O, small. Capital C, small O for cobalt. Mind you, first letter has to be capital, second cannot be capital. Say if you write second the letter also capital, it will become compound. It will not become element. So it has to be small letter. Second letter has to be small letter. Calcium is denoted by the symbol Ca. Chromium is denoted by Cr and chlorine denoted by Cl. That means first letter is compulsory. Then any letter from the name in small, cobalt, Co, then calcium, Ca, then chromium, instead of writing CH, what is there? Cr. Then chlorine, instead of writing CH, what is there? Cl. So chlorine. Okay, this way he assigned symbols to the elements. Then number 3, these symbols also represent an atom of that element. So the symbols are simply not the name of the element. They are not. They do not give name of the element. They also represent. They not only represent an element. They also represent an atom of that element. If I write C, capital C, means that is element, name of the element carbon, and it signifies one atom of that element. It signifies one atom of that element. So symbol represent an atom of that element. Then example, H represents the element hydrogen. H represents the element hydrogen as well as one atom of hydrogen. C represents the element carbon as well as one atom of carbon. Some symbols have been taken from the names of elements in Latin, German or Greek. So some of the elements are given symbols from their Latin, German or Greek name. For example, the symbol of iron is Fe from its Latin name ferrum. Sodium is Na from natrium. Potassium is K from kalium. Copper is Cu from cupron. Therefore, each element has a name and a unique chemical symbol. That's why each element has a name and a unique chemical symbol. Okay, you can see here. Table 5.1, names and symbols of some elements derived from Latin and Greek languages. So those elements whose symbols are derived from Latin and Greek languages. So name in English, sodium. Latin name, natrium. Symbol, Na. You must be thinking why sodium is not S. Why it is Na? Because of the Latin name natrium. Potassium, kalium, K. Magnesium, magnesia, Mg. Aluminium, alumine, Al. Calcium, calx, Ca. Then iron, ferrum, Fe. Now there is no F in the name iron, then how come ferrum? And how come Fe? It is because of its Latin name ferrum. Then copper, cupron, Cu. Zinc, Zinke, Zn. Silver, argentum, Az. Then gold, aurum, Au. Mercury, hydrogen, Hg. Then lead, plumbum, Pb. then team, STEM, SN, antimony, stevium, SB. So you must be thinking, okay, their names are different and symbols are different. So if you think like that, then you can just be sure that this is because the symbols are from their Latin or Greek name. Okay, then those elements whose symbols are derived from their English names are as follows. See, names and symbols of elements derived from English alphabets: hydrogen H, nitrogen N, oxygen O. First letter only. This is very easy. First letter of the name itself: hydrogen H, nitrogen N, oxygen O, carbon C, sulfur S, phosphorus P, boron B, chlorine C, fluorine F, bromine B R. Because B cannot be assigned for both, Br, then iodine I, arsenic As, platinum Pg, germanium Ge. Then helium He, neon Ne, argon Ar, krypton Kr, radon R and N, xenon Xe, chromium Cr, cobalt Co, radium Ra, manganese Mn, nickel Ni, barium Ba, uranium U, silicon Si. This is the way how symbols are assigned to the elements. And my dear students, you make this table 5.1 and 5.2 in your copy and learn. Because without learning the symbols, you cannot do anything in chemistry. These symbols means alphabets for English. So without knowing the alphabets in English, you cannot be able to write the words. Similarly, without knowing the symbols, you cannot write compound or molecular formula. Then comes valency. After symbol, in this one, in the language of chemistry, first of all is symbol. Then how this particular element can combine with another element, because we know that most of the atoms are unstable. Few atoms are stable, they are inorganic gases. So these unstable atoms combines with another unstable atom to form a stable molecule. And for this combination, they have some capacity. Combining capacity. And this combining capacity is called valency. So what is valency? Let's read out. Valency is the combining capacity of an atom, of an element, or of a radical with the atoms of other elements or radicals to form molecules. So what is valency? Valency is the combining capacity of an atom, of an element. If it is element, then combining capacity of an atom, or of a radical with the atoms of other elements or radicals to form molecules. So it is the combining capacity of an atom or radical to form molecules. Because molecules are stable and each and everything in the universe likes to be stable. So the valency of an element or of a radical is the number of hydrogen atoms that will combine with or displace one atom of that element or a radical. Now in other words, we can say that valency as the number of hydrogen atom which can combine with particular element. How many hydrogen atom a particular element can hold, this becomes its valency. Let's see with example. See here, the valency of hydrogen is taken as 1. So what is the valency for hydrogen? 1. That means hydrogen, whenever it has to combine with another elements, it can contribute 1 electron. That means its valency is 1. So in hydrogen chloride molecule, what is the formula? HCl. 1 atom of chlorine combines with 1 atom of hydrogen. 1 atom of chlorine combines with 1 atom of hydrogen. Hence, valency of chlorine is 1. So, in HCl, how many hydrogen is there? 1. So valency of chlorine is 1 because hydrogen, valency of hydrogen we know that is 1. In water, how many hydrogens are there? 2. That means valency of oxygen is 2. In ammonia, how many hydrogens are combined with nitrogen? 3. So valency of nitrogen is 3. In methane, how many hydrogen is combined with carbon? 4. So valency of carbon is 4. So by seeing the number of hydrogen atoms combined with another element in a compound, in a molecule, we can come to know about the valency of another element, provided it is hydrogen. So if the number of hydrogen combined to a molecule is 1, then its valency will become 1. Okay, then that's there. Then okay, if I say what is the valency of sulfur if the molecule associated with hydrogen and sulfur is H2S. In H2S, what is the valency of sulfur? 2, because there are 2 hydrogen atoms. Yes? Okay, so in NaH, sodium hydride, what is the valency of sodium? 1, because it has only 1 hydrogen. So this way also we can come to know about the valency of another element, provided the known element, provided one of the element is hydrogen and it is a binary compound. It is noticed that the valency, combining capacity of elements, increases from 1 to 4. That means valency first of all increases from 1 to 4 and then again decreases to 1. First of all, valency increases from 1 to 4, from hydrogen chloride to methane 1 to 4. That means chlorine 1, then oxygen 2, then nitrogen 3, then carbon 4. Again it decreases. So for example, for some values like helium, neon and argon, the combining capacity is 0. So why these elements have 0 combining capacity? Why these elements do not combine with other elements? It is because they are already stable. They do not need to combine. And why other atoms are combining? To become stable. Because they are inert gases and their outermost cell is complete. So their outermost cell is complete and no need for combining. But other atoms, other than these inert gases, other elements, their atoms are unstable. Their atoms do not have complete outermost cell. That's why they combine with other elements, and that's why they will have valency. But valency of inert gases is 0. You can see here how it increases and decreases. Name, symbol and valencies of first 20 elements. This table also will do in copy. Name of the element hydrogen, symbol as valency 1. Then atomic number 2, helium, valency see here. For atomic number 1, hydrogen, valency 1, helium 0, then lithium 1, beryllium 2, boron 3, carbon 4. Again it decreases. Nitrogen 3, oxygen 2, fluorine 1, neon 0. Again it increases 1, 2, 3, 4, 3, 2, 1, 0, 1, 2, so on. So first of all it increases from 1 to 4, then it decreases from 4 to 1. 1 to 4, 4 to 1. It goes on like this. So you learn the valency of these elements, at least for 20 elements you learn valencies and the symbols also. Now variable valency. Some of the elements, they exhibit not only one valency, they not only have one combining capacity, they have different combining capacity in different conditions. That's why they show variable valency. So certain elements exhibit more than one valency, that means they show variable valency. So some of the elements, they show more than one combining capacity, and that's why they are said to have variable valency. If an element exhibits two different positive valencies, then suffix US is used for lower valency and suffix IC is used for higher valency. So, if valency. Then the higher valency will be ending with suffix IC, and the name of the element with the lower valency of the same element will be ending with OUS. Nowadays, instead of using suffix OUS and IC, the valencies are written in Roman numbers under brackets beside the name of the element. So nowadays, in order to reduce the confusion of OUS and IC, IUPAC have given a very nice way of writing higher and lower valency by using Roman numbers. On the brackets beside the name of the element. Example, ferrous is written as iron in bracket 2. Ferrous means with lower valency, ends with OUS. So ferrous means valency plus 2. So it is written 2. And ferric, IC means higher valency. It is written as iron in bracket 3. So ferrous means Fe plus 2. Means it is showing valency 2. And ferric means valency plus 3. Means it is showing valency 3. So if valency is 2, it will be written iron 2. If valency is 3, it will be written iron 3. Non-metals like nitrogen, phosphorus and sulfur also show variable valency. Sulfur also exhibits a valency of 2, 4 and 6. So non-metals also show variable valency, but for those non-metals we do not use these Roman numbers. These Roman numbers are used for elements, especially metals, showing variable valency. For non-metals we do not use. So what is the valency of sulfur? It can be 2, it can be 4, it can be 6. So you can see some examples here. Table 5.4, metals with variable valency. Table 5.4 will see metals with variable valency. Elements copper, iron, silver, lead, tin, mercury can show variable valency. Copper, iron, silver, lead, tin, mercury can show variable valency. That means they can show more than one valency. They have more than one combining capacity. So symbol for copper Cu because of its Latin name cuprum, iron Fe because of its Latin name verum, silver Ag because of its Latin name argentum, lead Pb because of its Latin name plumbum, then tin Sn because of its Latin name stannum, and mercury Ag because of its Latin name hydroxide. So see, lower valency state Cu plus. There is only one positive charge, means valency is 1. And in Roman, in the modern way, in IUPAC system, it can be written as Cu in bracket 1. So Q plus. And higher valency Cu2 plus means valency 2 here. 2 plus means valency 2. 1 plus means valency 1. And in Roman it is written as 2. So the name will be cupric. Lower will be OUS, higher will be IC, cupric. Then Fe2 plus, ferrous, Fe3 plus, higher valency, here is 3. Ag plus, Ag in bracket 1, argentus and argentine. Plumbus, P4 plus, plumbing. There is no 3 for lead. Then Sn2 plus, stannous, Sn4 plus, Sn4 stannine. Then mercurous with 1 valency, mercury with 2 valency. Okay, then this much for today. Hope you will make this table 5.1 to 5.4 in your copy and you will learn it. Till then, you stay safe, give time to your studies, help your parents. Thank you.